Hello and welcome everyone. This time I'm making a JUCE tutorial that is actually very close to the JUCE framework, and you should watch this video if you are a beginner at this framework. The topic of this video is parameters. How are parameters created in the audio processor? How are they, let's say, referenced in the GUI, in the plugin editor? How does the connection between the two work? And how can we make our lives easy while setting all that up? Those, and especially the last one, is something that I haven't seen a lot in videos like this yet, so I just decided that I want to make my own video. As you can see, I already set up an example project and I'm going to explain to you what the things are that I already did. You can already see there is a parameter called wet gain. It has a range from -12 to 12 decibels. At the moment the audio output is muted, but I already tested if it works, so that's okay for me. So this is the process block method. I'm doing the things that you always do: check if there are samples, and if yes, then clear all the channels that are not used, and then getting the gain value from the AudioProcessorValueTreeState with get raw parameter value load, and then converting this gain value into normal gain values that are not decibels so that they can be applied to the buffer. This is the crudest method that you can use to add gain to some audio signal, and I will just use this method now. But let's start from the beginning. In the producer, you set up a new project, and obviously you are setting up a plugin project. Give it some name and then hit create project. Then what I did is I added another header file that was still empty at the beginning. Of course, add new header file, and exporters enable plugin copy step, so that when you want to debug the thing as a plugin, you can always do that. Now in the plugin processor, you make an instance of the AudioProcessorValueTreeState. You include your new params header so that you can use whatever you write in it. And then in the CPP file of the plugin processor, you instantiate the APVTS with this null pointer parameters, and your parameter namespaces create parameter layout, a function that you still have to write. Then, as I already mentioned, there is process block where not a lot of things happen, and I'm currently setting the editor to false so that the plugin loads with a generic editor. This also works in DAWs, because all DAWs that I know have a feature where they give a plugin that doesn't have a UI on its own a generic editor, so that it can display and let you tweak the parameters even though you are not specifying a GUI. Okay, so how does my parameter namespace work so far? I have included JUCE audio processors, JUCE audio processors.h, because it has all of the stuff that we need. Then I defined some things so that I don't have to write so much later. And then the method comes, create parameter layout. It creates the layout. As you can see, an AudioProcessorValueTreeState parameter layout. It creates a unique wrap vector, which means unique vector of wraps, ranged audio parameters. And then I added a free function called create param that gets this vector and adds a parameter to it, and at the end you are returning the parameter layout. And we will add more different parameters to this later, and also add more arguments to this method to make it more flexible. At the moment, this method can only create a gain wet parameter with this ID, with this name, with this exact range, with this exact default value, with this exact unit, a generic parameter, and a ValueToString and string-to-value lambda, which doesn't do a lot, like it just converts a float value into a string or a string into a float value. Not much to it. Now let's solve one by one all of these problems. The main problem that I'm seeing here is that we have a string compare in process block, and that's often sometimes that people don't want to see, because this takes a lot of CPU, and it might also allocate memory, because strings are basically like dynamic arrays. So we want to get rid of this, and we could do that by just having our own vector of parameters in the plugin processor. Let's see if I can just use param unique wrap vector for the parameters. Now we can see that we have a problem. We want to loop over the parameters of APVTS so that we can put them into a vector of parameters on our own. Let's just say that this for loop works in some way. Of course it doesn't. So what we want to do now is params push back, and then APVTS get parameter. We want to get the ranged audio parameter pointer, and we want to have the parameter ID in here. How can we accomplish that? Actually, I have to rewrite this a little bit. We want to have a vector of ranged audio parameter pointers. So we need to somehow accomplish that, because then when we have this vector, we can replace this with params, let's say 0. And instead of load, we can just use get value, which will be the normalized value between 0 and 1. We still have to convert that to the denormalized value. Convert from 0 to 1 to the denormalized value. So now what happens here is we're getting the normalized value from the parameter, assuming that it's the first parameter, even though this is not very clear yet. It will become clear. Then we are converting that to the denormalized gain in decibels value by getting the normalizable range out of this, and then converting from 0 to 1 to, well, whatever range it is. And then we are converting to gain, and then we can apply the gain. So this is still quite cryptic, and this up here is also still not working. So how is the question? And in order to answer this question, we have to go back to our parameter namespace, because what I would like to suggest to everyone now, and that's also how I handle parameters myself, is to make an enum class where you just list all of the parameters you have, and at the end you call the last thing num params. And I always like to call this thing PID, because it's the parameter ID for me. Now you can basically do this in order to get num params as a number. So as you can see, since there is just one parameter in here, then this is 1 num params. If you added another one, then this would be 2. Just have to make sure that you never write something after num params, because that makes no sense anymore. Now it would make sense if there was a method that can convert the PID into a string, so that we can replace that with this kind of stuff. We would just have to have another argument in here, which is the PID that is currently used, and it would automatically figure out what has to be written here in order to do that. One way to do that would be to just say there is a toString method which gets a PID, and then there is a switch case where it returns a name if it knows a name. In most cases, when you're trying to make an enum class be a string, it makes sense to call it toString. But in this case, I would like to call it toName, because we have to make a difference between the ID and the name. So now we need a method that is called toID, and it basically gets the name as an input argument. And now we want to have name to lowercase, and also with removed empty spaces. And we can finally generate these arguments from just this input argument. Let me rewrite this a little bit so that we can have a better overview over the things that we still have to accomplish. Alright, so the next thing that would make a lot of sense to have in here is, of course, the range. I would suggest that the range should also just be an input argument. Of course, with range I mean normalisableRange float. And we need an argument for the default value. And of course also for the unit. Now let's take a break from going on, because we could also go on with the ValueToString function or the string to value function already. We wanna skip that for a little bit later, because I have something in mind that I wanna do here. You will see what I mean. Let's go back to the processor and see how many things we have already accomplished by doing so. One of these is we have something that we can put here. We can now say num params is the value that we wanna use. What we can also do is we can actually create a parameter ID for every index value of this loop. At the moment, this will only be one value, which is gain wet. But we can now say param to name PID, and of course param ID to ID of the name. Now this looks a little bit convoluted, but we can make our lives a little bit easier here as well by just writing string to ID and give it the PID as an argument directly. So we have that as a method as well. We can go back here and directly input PID now. Now that looks more like it. What else can we do now? We can actually go down to process block and we can say param PID gain wet. It doesn't work out of the box because you still have to cast this to an integer so that you can actually use it to read something from an array. Now we have this here twice. Gain wet PID is this. And suddenly we can just write it down like this and it already looks much more reasonable what's happening here. Now we can really read. We are getting the PID for gain wet. We are reading from the parameter gain wet, but it's normalized. So we denormalize it and then we go to gain and then we apply gain. Easy peasy. Now let's actually do something a little bit more interesting. We want to have a frequency parameter in Hertz. We don't have to modify any of these functions except to name so that we can add the return value for frequencies. And now we create a new function for the frequencies and it should range between 20 and 20,000 Hertz. So it is in the unit Hertz instead of decibels, and apparently the default value is 1000. Okay, that works, and we can probably also use it the same way in process block as we used the decibel value, which I already showed is quite a nice workflow because we can just get the stuff referencing the array. We don't have to add any lines in the audio processor to make this work because this loop is already looping through all the parameters that have been defined in the enum class and adds them to the array, and it can be immediately used in process block if I wanted to now, but I have nothing in here now that would use a frequency, so I cannot do that. So what comes now is more theoretical. You can see here that the frequency ranges between 20 and 20,000. And as you probably know, most plugins where you can select a frequency are made in such a way that 1000 Hertz is more or less in the center of the parameter. However, you can see at the moment 1000 is already here at the beginning, and in the center we have something around 10,000. The reason for that is that 10,000 is half of 20,000. So this is just a linearly distributed parameter, but that's not very musical. So you want to introduce a range, and that's where custom normalizable ranges come into play. So now somewhere between the parameter functions and the parameter creation functions, we will make a new namespace called range, where we define some helper functions that will help us create better ranges. So now I added some of the functions that I also have in my own plugins. There is a function that will just give you some biased range. That is one that has a curvature on it. There is a method that just gives you a stepped range where you can go in steps like 0, 1, 2, 3, 4, 5 and nothing in between. There is a toggle function which is basically just 0 and 1. There is a linear function which distributes stuff linearly. And there is a function that uses the bias function to make something where a specific value is in the center. I will not go into detail now how these work mathematically, but you can just check out the GitHub repository yourself if you want to find out more. I will just use them now, because now this enables us to actually say range lin minus 12, 12 to create a linear range between these values. And here we can now say range with center and define a center, for example 1000. Let's see what happens now. Now we actually have a frequency parameter where 1000 is in the center, and we have values below that go down to 20, and we have values above that go to 20,000, like it should be. However, we still have a different problem. I mean, look at these values. 3871.38 Hertz. Who the fuck cares? This is just 3.8 kilohertz. And that's also how we want to write it down. And that's why the ValueToString functions exist. So let's examine that again. If we have numbers that are smaller than 100, then it makes sense that we want to have 2 decimals to just look exactly what this value is. Just see exactly what this value is. So if value smaller than 100, return this. Else if value smaller than 1000, then return string value 1, I think. Let's try that. Else 10,000, at this point something completely different has to happen, which is value divided by 1000, so that we have k values. And then, oh, this is bigger than 1000 actually, bigger than or equal. And now string k1 plus k. Let's see what happens. Okay, now we can see if we are below 100, then we get 2 decimals. If we go over 100, we only get 1 decibels because it's just less interesting to have this precision then. And if we go over 1000, then we have the value in kilohertz with the nice little k added. But you can see it doesn't look very nice that the k is here and the hertz is here, because the unit of the parameter cannot change, even though we might want to have something like that in our parameter to make it most comfortable to the people who use the plugin. That's why I would always say just ditch the unit that is defined by JUCE itself, keep that empty, and instead use a unit only to display the value itself. So that would mean directly writing into here kilohertz, hertz, and hertz. You can see that this ValueToString now is not a generic ValueToString anymore, but now this is the ValueToString only for hertz. So it doesn't belong into this parameter creation method anymore, does it? I would say it does, but only if we give this another little twist. We have to introduce an enum class unit, and there we will have things like decibels and hertz and num units. And now we can just say toString with input unit and return the unit strings that are generally used, even though there is more to it than this. So now let's actually give a unit to this method instead of a string, so that it can generate the strings itself from it. So now I can just say unit decibel and unit hertz. You might wonder, how does that now help us? Well, it helps us because now we can just say there is a namespace for ValueToString functions and there is a namespace for string to value functions. Using ValueToString is now an std function that returns a string with the input of a float and an integer. And a string to value function is something that has a string and returns a float. So ValueToString decibels returns a string where it just writes decibels after it. At the moment, maybe we can tweak that later. And ValueToString for hertz is just what we wrote before. Now for string to val, we can also write one for decibels specifically. We could remove the characters from whatever decibels is, and also the same for hertz. Even though for hertz we have to make it a little bit more complicated, we have to check if it ends with k after having removed the hertz, then we still have to drop a character and have to treat the value a little bit differently. So you have to make this a little bit specific to the individual unit that you are writing. You have to make the string to value fit to the ValueToString. But once you have this overall structure, the cool thing is you can just remove this code and instead write ValueToString and string to val, and now make a switch case on what to do with these before adding them to the parameter. So as you can see, that was fairly straightforward. And here we can even now enter toString unit. Great, great. Now let's see how good this works. Of course it doesn't work. Maybe we have to inline them. Always forget that. Alright, decibels work very fine. And hertz works very fine as well. So now we have solved a lot of problems already, because now when we are creating a lot of parameters for our layout, we can think in very simple terms. Basically just give it the vector of ongoing parameters, tell it which one it should be, tell it its range, tell it its default value and what unit it is, and everything else will be figured out automatically. And that already gives us a lot less stress during programming than what I see usually done, where you are just really using the constructor directly all the time. This is much better because now you can just individually tweak the value to string and string to value functions of each parameter as much as you want. It will always be maintainable in some way, and you can also reuse all this stuff throughout your project, and you will get much more value to strings and string to value functions throughout your development. If you want to see some examples of that, you can check out my other repository with my plugin template, where I already have tons of these. Now let's actually start working on the plugin editor, because I want to show you that whatever we just did in the processor will also highly benefit us in the editor. Of course, we first have to enable the editor again by setting this to true in the processor as editor true. Now we don't need a destructor now, because I don't want to use look and feel. We only need paint and resized and our reference to the audio processor. Now, how do you want to represent your parameters? Most people would say they want to represent them with JUCE slider. So we have a gain weight slider and a frequency slider. You could also use your array here if you wanted to. I don't know if I want to do that, because it might be that you want to split up your parameters throughout multiple different components in this component system anyway. That's why I usually don't do that. But I think I will show you anyway, because it can be very useful. Let's say you want to include your parameter header and also array. Using slider is JUCE slider. Using slider array is as the array of slider param num params. So now I have a slider array instead of a single slider. And now in the plugin processor, we have the initializer list, which has a very weird layout in the default JUCE plugin project, because usually parameters are written like this in a initializer list. Now we have the sliders here. Iterate through all the sliders. We want to position the sliders now. This should now put all of the sliders into one line, no matter how many we have in the array. Of course, we still have to make all of the sliders visible. So let's already put a little loop in here. And now we reference the slider of each iteration so that we can do things with it. And one of the things is to make it visible. Slider set slider style, rotary vertical drag, the only slider style that really matters. Okay, now we got two knobs that are not connected to any parameters yet, and they are just going from 0 to 10, because that is the default range of JUCE slider. Now JUCE has the concept of a slider attachment or parameter attachment. JUCE parameter attachment. And now I could just define an attachment array as an array of attachments of also the size of the parameters. We make an attachment array. Now, obviously, we could just go on like that, but you can already see a little pattern here. If we have a slider array and also an attachment array, then why not subclass that so that we can just make a single array for both of these things, you know? So we will do that now. We have a struct. Let's also call it slider, or let's call it attached slider. And now we can say it has a slider and it has an attachment. Now we want to know what kind of arguments does this want from us. Slider, as we know, doesn't need any arguments. Attachment, however, wants to know the ranged audio parameter in question. So we need the ranged audio parameter reference, the parameter callback, which is function like this. It gets the parameter value as an input, and the undo manager, which we don't have. Now, where do we get the ranged audio parameter from? Maybe we could go in here with a param PID and with the audio processor. Because that would mean that we can now say processor params of param to ID of PID. That's how we can get the pointer out of it, and then we just have to dereference it. It doesn't like that. Alright, we don't have to use toID, but static casting to integer. And what should happen whenever the float value changes? The slider should repaint. I think that's all that we need for an attached slider. So now we can actually make an attached slider array instead of all this. Now going back here, we just have to give it the argument AudioProcessor and param PID gain wet. Obviously this is an array now, so we have to use the array notation of the initializer list, which goes like this: attached slider, input arguments, and then same thing again. All of these things will not work very nicely anymore, but the cool thing is now we can actually shortcut some of these things in our main code, which is always very nice. For example, just set the slider style in the constructor of attached slider, so we don't have to say that here anymore. Now add and make visible slider doesn't work anymore, but we can just turn it around. We can just make a function called add and make visible, and it should have a component as an input, and that component then adds and makes visible the slider. So now we can use that method. We could also just read from the member variable that is public in the attached slider anyway. It would just look like this: slider.slider. Yeah, actually I like that more as well because it's a bit more familiar. So we can do the same here. And now we should have attached parameters. Of course it doesn't work. Why? The processor params don't have memory yet. Can it really be that the editor is created after the processor? That would suck. So what happens when we run the code now? As we can see, still there is nothing new. Our sliders just go from 0 to 10, because just because we have these two objects here doesn't mean that they are attached to each other yet. By the way, we have to be more specific here. This has to be a slider parameter attachment. And instead of this argument, it just gets the slider as an argument. That is a little bit problematic because it means that you have to do all this again for the other parameter types that you have in your project, like buttons, radio buttons, XY pads, or ADSR envelope generator representations, whatever you can think of. Usually it would be good if there was just a general attachment that works for all parameters the same, and I managed to do that in my own project, but I just realized that it would be a bit too much of a hassle to describe how I did that in just this video. So I will just only talk about how to accomplish this with the slider parameter attachment, well, which is like this. So now you can see that this slider is actually representing the correct range and also the correct unit, and it's displayed correctly as well, and we have the same thing happening on the frequency parameter. Of course, there is still no label that says that this is gain wet and that this is frequency of whatever cutoff filter or so, but you know, that's something that you can figure out yourself how you want to display that. Now I want to actually build this as a VST plugin and run it in the DAW because I want to show you something else about this. Okay, I'm in Bitwig now, and let's say that I want to instantiate a copy of the parameter example plugin. We can see it here. And now down here we have the little representation of the plugin. Every plugin has one of these representations in Bitwig. For example, if I load ProQ, then I can scroll through all of the hundreds of parameters that this plugin has and modulate them individually down here as well as in the plugin GUI itself. Other plugins have a non-GUI representation like that as well, but it's especially important in Bitwig, as Bitwig has a modulation system that lets you, apply a general modulation across multiple plugin parameters and also multiple plugins. So you can see when I'm tweaking the parameters, not from the GUI, but from the modulation system, or the same principle would apply now if you used an automation. That is a thing in all DAWs. And as you can see, that works because the way I implemented the parameters, the GUI does not hold the parameters itself. It is just referencing them, or with the attachment being attached to the parameters. So when the parameter value changes because of something that did not happen in the GUI, then the GUI is informed about that because of the attachment. And that's why it was important to set that up. Another thing that we can see here is that Bitwig also displays the correct value and also in the correct way with the 1 point something kilohertz when the hertz is above 1000. And that's why I wanted to show you specifically how I set up this whole range stuff, you know, my whole workflow with ranges and with value to string lambdas and string to value lambdas, because that way you just get a very clean workflow and results that work absolutely the same in the plugin editor, so in the GUI, in the window, as well as in the entire DAW. That's just how you want it to be. When you're making an automation here in Bitwig, it is shown in %, so that doesn't show the correct value. But if you did the same thing in Cubase, it would also show the correct value in, what is this, decibels. That's just a thing about Bitwig that they didn't implement that yet. But yeah, automation has to work just the same with a parameter. Okay, so the main takeaway from this video should be not only that my workflow in general is hopefully very understandable and good, but also that parameter attachments do not have to be in a unique pointer. Because a lot of tutorials out there that try to show you how to set up the parameter layout on the GUI side want you to put the parameter attachment in a unique pointer. And of course it can make sense to use unique pointers for parameter attachments. For example, if you want to reuse the same slider for different parameter ranges and you just want it to only be attached to one parameter at a time. And another use case of unique attachments is if you want to have a vector of attachments. That can be, for example, a thing if you make an EQ pad like in Pro Q, where there are these little knots that you can touch and every knot represents a bunch of parameters like cutoff, frequency and resonance. So basically if you were to select multiple knots at the same time, then you would also, when you are touching the cutoff, want all of the cutoff values of all of the selected filters to move. So that means that one slider would basically have to be attached to multiple parameters on the processor. But you don't need attachment to be unique pointer on itself. It can just live here normally like every other object, because with the power of the initializer list in C++, you can just give it the values that it asks for in the constructor immediately. Yeah, and then in your plugin editor, you don't have to write a lot of stuff anymore. You just have to define all of the parameters, just the basic things, like you want them to come from the audio processor, and this is the ID, and that's it. Add and make visible, background color, positioning. You know, this is just the most straightforward way I can think of defining what should happen in the plugin, and that's why I wanted to present this to you.